In pretty much every psychology class ever in the history of the universe, I think they write it into the rule book. The second unit is always research methods. For the most part, it's just called methods, or scientific method, or research. And we start off by saying, does anyone here know a fact? Can anyone here give me one fact? No one. Go ahead. Oranges are orange. I disagree, sir. Because I had orange juice this morning and it most certainly was not orange. It was yellow. Okay. It's a warm, welcoming environment in this class. So what we're looking at, the idea here is research. What do we know and how do we know it? And I think whenever anyone ever teaches a class in research, you almost hear a collective psychic groan. People roll their eyes, oh, research. I think there's a couple reasons. I think a lot of people don't teach it well because they force students to do research on what the teacher wants. And students really can't research what they want. I think everyone's curious. I also think that, research is slow. To do it right, man, you got to do painstaking step by step. And people want the answer right away. You can't just wiki it and say, call that research. So there is some pluses and minuses with this. It can be fun if you are doing something you want. It can be horribly torturous if you're doing it on something that you have to research and you have no love for, and if you just want to jump to the right answer. So what we're going to look at, we do have to slow it down a little bit, but hopefully we're going to present it in a way that makes it look a little bit more interesting. So, let's start with this. 47.23% of all statistics are made up on the spot. Go ahead, please. Yes, I did make this up. So those of you who are writing this down, shame on you. I actually just told you most statistics are made up on the spot, and you wrote that down. Look, 4 out of 5 is 80%. Somebody writing that down. Don't write that down. What I'm showing you, 5 out of 4 dentists can't do math. So what I'm showing you... Well, somebody, what did you just say? What I'm showing you is that statistics aren't facts. And I think one of the most misused sentences in the world, or phrases, is when someone says, research shows. Research can show anything you want it to, especially bad research. This is something we need to be really careful of. Who did the research? How they do it? How they report it? Are you misquoting what the research says? Let's look at things like Luminosity, BrainTrainer.com, or anything that's purported that if you do this, then you will be smarter. And I'm a little bit suspicious of that. How do we know what science tells us is the truth? You know I'm going to hold you responsible for studying Chapter 2. You know I'm going to hold you responsible for learning about research methods. How do you know what is in your textbook? How do you know what I tell you is the truth? I could be making this stuff up. You'll never know. You'll study it. You'll get an A on a completely made-up test. You go out in the world thinking the ninjas won the Civil War. And how do you know? So we really need to look at what is the truth. Let's jump on to something I call sloppy thinking. Sloppy thinking, well, some examples of it would be rumor, prejudice, coincidence. And we look at these as fact. But I'm actually going to go so far as to say this. I think sloppy thinking, rumor, prejudice, coincidence are actually pretty good. There will be many times when in other classes where professors are going to say, don't use prejudice, don't use coincidence. You need to examine the facts before you make a decision. And I say maybe. I actually suggest jumping to conclusions is usually a great strategy. Using prejudicial thinking is usually a great strategy. You go, oh my gosh, you can't be prejudiced. Well, let's look at this. I'm going to make a conclusion before I have all the facts. I would like you to imagine you're walking down, you're walking in the woods. And there's a bear, pops out at you. What do you do? If you are going to follow other professors who say, well, first gather all the data. So what are you going to do? You're going to take out your phone and you're going to maybe it's an escaped circus bear. Maybe the bear's not hungry. Are you going to say, here, bear? Are you going to run? What are you going to do? And I suggest until you gather all the data, anything you do is flawed. You run away screaming. It was an escaped circus bear. How many of y'all would like a pet bear? That's what I'm talking about. If you had a pet bear, all right, and you brought it to school, and your teacher said, no bears in class, what are you going to say? You're going to say, it's a bear. Bear, eat him. How many of y'all would like to ride a bear? That's what I'm talking about. It'd be the best thing ever. How many of y'all would get a bear saddle? Are you kidding? I mean, the coolest thing ever. I'd be on the back of it, but I'd have 4 mini bears who could like launch and go get other people just in case. How many of y'all want out of this class right now? All right, that's what I'm talking about. All right, so let's talk about top-down processes. When we talk about top-down processes are an example of sloppy thinking. It's a fancy name for jumping to conclusions. Top-down processes. And we're going to hit this word a little bit later. When we say top-down processes, it means, look, it means we get the conclusion and then we find the data. It means ready, fire, then aim. You're not really supposed to do that. First you gather the data, and then you think, then you draw up an action plan. Most of us don't do this. You might think, I'm a logical thinker. Maybe you are, but I don't think you can or should do this at all times. Now, of course, this does lead us into some problems. You're walking on a sidewalk, you see someone, and they say, hey, what's up? You're like, fine. I mean, nothing. You never do that? Where you assumed the conversation was going to ask, what's up? You said nothing, or you thought they were going to say, how are you? And you said, fine. You jumped to conclusion, you gave the wrong data. It does happen. But you know what? Human beings are actually pretty good at thinking shortcuts. Thinking shortcuts? What the heck's a thinking shortcut? It's called a cognitive bias. Cognitive bias is another name for thinking shortcuts. Human beings are not as fast as computers, so we do need to jump to conclusions. We do need to say, holy crap, that's a bear. While it could be an escaped circus bear looking for a home, I'm going to assume it's a flesh-eating monster. I'm going to leave the area faster than my friend. In fact, I might trip my friend, so the bear will eat my friend and I can get away cleanly. We've got a lot of people in this class that are pretty smart. So I would like you to prove this wrong. I would like you to disprove this statement. In the winter, the act of you waking up causes the sun to rise. Anyone? One more time. In the winter, the act of you waking up causes the sun to rise.
I'd like you to disprove.
Go ahead. Never mind. I almost saw the gerbil on the wheel. All right, then. Go ahead.
You live in Alaska and the sun's already there.
This is a good point. You live in Alaska and the sun's always there, already up. What if I were to suggest
that if you wake up at a certain point on one day out of 365, that will cause the sun to rise on another day? So it might not be the same day.
But if you wake up in mid-December, it's going to cause the sun to rise in February. Go ahead.
What if some people are nocturnal?
What if some people are nocturnal? Well, then they wouldn't know if the sun ever rose. Go ahead. Anyone? Go ahead.
What if you never woke up and the sun would still rise without you?
How would you know?
Other people would know.
But if you woke up, you'd never get to hear it from them. Go ahead.
If you wake up in the afternoon, the sun's already up. But again, if you wake up in the afternoon on Saturday, really, because you woke up in early morning Friday, that caused the sun to rise on Saturday. Y'all better be careful now. You could be the one. Out of 7 billion people, you could be the one.
And if you
wake up, that's it. What if everyone does have one day? And your responsibility, your only purpose on this universe is to wake up that one day. If you don't, total darkness. You seem worried by this. All right, no sleeping in. So what I'm saying, because you never know, the whole world will be mad at you. What I'm suggesting to you is, how do we know there is not a causal relationship? You're like, causal relationship? What the heck are you talking about? We're looking at causation, or a causal relationship. One event directly causes the other. So when we look at causation,
one event
causes the other. It's really hard to find in psychology. What causes depression? What causes mental illness? What causes genius? what causes happiness? That's tough to see. Now in physics, because physics is such an easier science, you could take 2 billiard balls, 2 pool balls, put them on a table, and you could roll ball A, and it hits ball B, and ball B starts to roll. And we could say, aha, ball B's motion is directly caused by the impact of ball A. That's easy. And it doesn't matter who the researcher is, what the researcher's values are, morals are, ethics are. It doesn't matter if the researcher is female. All right, it doesn't matter if the subjects are male. If we can't find causation in psychology, then we must find correlation. Correlation's kind of like the uglier step cousin. It's not right to say, but we want to find causation, but since it's so difficult, what causes depression? Well, does child abuse cause mental illness? Maybe. Do you think child abuse and mental illness are related? Yeah, I think so. Okay, so the question is what caused it? In psychology, it's pretty impossible to find. Would you agree the act of you waking up is connected to the sun rising? Is there a relationship? Do they both happen in the morning? As ice cream sales rise, so does the murder rate. That's a scientific fact. That is a sociological and criminological fact that's been replicated for decades. I am not making that up. Ice cream sales and murder rates are directly correlated. You're like, what the heck? Nuh-uh, it's true. I don't know the cause of the relationship, but the relationship is pretty strong. Is that people are like, look, I'm not, and then like the little thing falls. Like, oh, that's it, someone's dying. Is that what it is? Or maybe y'all are hardcore thugs, man. You just go bust a cap and something like, you go celebrate with some ice cream. I don't know. I'm pretty sick if it is. Or maybe we can establish their relationship, but maybe there's a third variable. Maybe the concept is simply that they both happen in August. And heat, of course, is going to increase ice cream sales. And for a very strange reason, heat increases aggression and frustration. And that might be the tipping point between someone being so angry they cross the line into violence and murder. So, ice cream sales and murder, or you could also say ice cream sales and drowning are strongly correlated because they happen in the summer. All right, these next two things we're not going to spend too much time on because I'm assuming you have passed 4th grade math. Okay, a scatter plot is simply a graphic representation of a correlation. If there's Y, then there's X. And then if we've got a scatter plot, then we're going to obviously be able to figure out what's called line of best fit. And line of best fit simply means it's a graphic representation of where the data falls on a graph. Now, you're like, well, why are we talking about 4th grade math in a psychology class? Well, because we do want to study the relationship between certain events. I think we could acknowledge there's a relationship between previous childhood abuse and mental illness. And I think maybe we flirted with the idea that there is relationship between intelligence and height. There is. Intelligence and good looks? Yes. But not if you're blonde. When we talk at scatter plots and line of best fit, it brings us to the word correlational coefficient. Correlational coefficient. I think the concept's pretty simple. It's basically one number, or you can just say the slope. The slope of a line that's going to determine the relationship. And I think we could have a pretty clear positive correlation. Height and weight. While not perfect, generally the taller someone is, the more they're going to weigh. There could be someone who's really tall and really, really, really skinny. When we talk about correlational coefficients, all right, you really have a range. And the range is -1, which means there is an opposite or negative reaction. For every ounce or unit of testosterone in a body, there is more femaleness. Like, nuh-uh. I think there is a relationship. Is there a relationship between testosterone and femaleness? Say yes. It's a negative relationship. Is there a relationship between intelligence and growing up in a southern state that ends in A? Yes, it's a negative relationship. You don't believe me? Go to Alabama. What we're looking at is just because the relationship is opposite doesn't mean it's not a strong relationship. And you could look at politically. People who are Republicans generally don't want high taxes. The opposite is going to be a positive relationship. Perfect one. Which means for every X there is a Y. For every X there is a Y. For every inch you grow, you put on an extra pound. And of course, there is no relationship. So you have a range. It's either perfectly negative, perfectly positive, or there is no relationship. And the relationship would be no relationship. What about eye color and wealth? Eye color and height. Do you think there's a relationship? No. Is there a relationship between height and weight? Yes. Is it perfect one? No, but I bet it's about 0.9. That's a pretty strong relationship. You can never get above a perfect one, but you can certainly get somewhere between these. You could have a 0.5, 0.4. You could have a negative 0.4. Regression to the mean is the idea that you take a bunch of numbers over time. You take enough data, and you kind of get the truth of it, or as close to the truth as we can. So I'd like you to take your GPA. Your GPA is a measure of you over time. And with enough data, that's a pretty strong measurement, which is kind of good. I mean, if you totally fail a test, and you get like a 20%, or you figure out a way to actually get a negative percent and take knowledge away from people near you, that's how badly you scored. Well, guess what? It really isn't going to affect your GPA that badly if there's enough scores, which is kind of good. Now, on the other hand, the bad side of that means you probably can't raise your GPA too much. Once you've established enough data, 1 or 2 or 3 really good grades, even a good semester, might not change it that much. That's kind of scary. So, why even try then? Exactly. Give up. That's what I'm talking about. All right, delete that. All right, so but let's talk about the Redskins. Praise be their name. 1992, all right, which is also the year Breyer's Mint Chocolate Chip Ice Cream came on the market. Same with pretzel M&Ms. It's a trinity of goodness. All right, the Redskins went 14-2 and won a Super Bowl. So what the heck am I saying? Actually, the last 2 games they lost, they pulled their starters. They were so good, it was just like they were beating people like ugly children. It was just silly. We don't beat the good-looking ones. Why would you ever beat a good-looking kid? That's silly talk. Pick the ugly ones. So what I'm saying, so like, that's not fair. And the other kid's like, it's true. All right, so that's not right. Why would I say that? Why do we care about this? Look over time. Their average is 8-8. They win 8, they lose 8. Some years they win more, some years they win less. But over time, you get enough data and you get a good measurement, and it really doesn't matter. You'll find out average. People are average over time. Who gets studied? Participants or subjects, or both? Again, in psychology, we have to define our terms. It used to be we just called everyone subjects. That doesn't sound right. Participants, especially human participants, sounds better. Because I think participants, it implies a voluntary idea. They signed up. They want to be there. Subjects means you're just a lab rat. Someone with a lab coat, someone with a microscope and clipboard is studying you. And it implies that you can't change. Now, I guess a rat can't hire a lawyer and say, no, don't zap me, don't shock me, don't put me in the maze, don't dissect my brain. I don't want this. But if you're a human, we're going to find out there have been studies. There have been studies where, guess what? Humans kind of got tricked into being into a study, or got tricked into thinking they couldn't get out. They got manipulated into thinking they couldn't get out. And the idea of being a psychological
Subject, that's scary. Who wants to be a subject?
subject, but if your participant implies control, you can drop out anytime you want. So we call humans psychological participants. Look at the word population. Population is the whole group from which you can draw from. Our school has several thousand students. That's our population, and we denote it by uppercase N in italics. So, sample size is denoted by lowercase n italicized. So of 500 or 2,000 or tens of thousands of people at a school, who did you pull? How many of the whole population was your sample? And you should write down, the larger the sample, the better the study. That's a positive correlation. If you only study one person, how do you know that one person wasn't abnormal? If you had an alien come down to our world and they could pick any one of the billions of people who have ever lived and they happen to study Gandhi, or they happen to study Adolf Hitler or Joe Stalin or Martin Luther King, if they only study those 4 people, all right, well, that's not going to be a good study because it doesn't, when we're going to learn this word, represent
The whole population. So your sample size
should be large. Let's talk about demographics. That's a lot of syllables, big scary word. Let's break it down. Anyone know what democracy means? Should mean rule by the people. Well, demo means
people. Graph means
measurement or picture of. So demographics is going to be a study of the population. Study of the population. Why do we care? Well, because if I do an exhaustive study on autism, and I have 500 participants, and I show that autism is on the decline, but I look at the demographics of my samples, my sample size, and for my participants, and I find out that I studied, check this out, I had a huge sample size, 500 people, and I showed that autism is on the decline. What if I studied 500 82-year-old women? You can see that my demographics probably aren't really representative of who I should be studying. I probably should be studying men. Random sample. It's tough to get. Thousands of people in the school. How are we going to pick them randomly? It's easy to design or imagine. It's easy to imagine a perfect study. But in reality, there's no such thing as a perfect study. Go through the phone book. A lot of people don't have their names listed. If you use the phone book as a sampling technique, a sampling method, by definition, you aren't going to get any homeless people in your study. And since there are a certain percent of homeless people in our population, we should get homeless people in our study. So how do you get a random sample? Do you say, you, come on, be a part of my study? Well, that sounds great, but you chose them at a time and a place. What about people who are going to school at night? What about people who happen to be studying a religious holiday and they weren't on campus at that time? You just excluded a whole group of people who have a different religion than you. Getting a perfectly random sample, it's tough. It's really tough. What if you were to go through the registrar's rolls and pick all of the student IDs that end in an odd number and student IDs that end in an even number? Maybe we're approaching randomness. Let's look at a representative sample. What if you do? What if you get a random sample and miracle of miracles, you draw 500 people, but 400 of them happen to be male? Well, that's not representative because half the people in the universe are female. So what do? You say,
holy smokes, I need to get more women.
You say, all right, you look like a woman. Come here. You should be in my study. You probably shouldn't say just like that. All right, you look like a woman, probably not really that flattering. What if you choose 100 people and they all happen to be white? They all happen to be African American, all happen to be Asian. How do you make sure that your group of people you choose matches? And if you say, well, my group of people doesn't match, so I'm going to go draft some more white people. You walk around, okay, hey, you look white, come here. Can you be in my study? You're African American? Come on. Oh dear. Now you're starting to get into some weird concepts of how do you make sure your sample matches the whole population. Random assignment. Random assignment simply means if you get 100 volunteers and they sign up, they'll do it. They'll take your pill. They will go through your test. They will sleep a certain way. They'll keep a journal. They'll do whatever it is you're asking them to do. How do you put them from one group into another?
Because one group might
Get the real ADD medicine, and the other might get the fake pill. How do you do that? And I think you're going to obviously need to do it randomly. Do you do it by birthdays? Do you do it by male, female? Hypothesis has been described countless times. I'm going to try to describe it to you in 2 words. 2 words and 2 lines. All you should write down, a hypothesis is if blank, then blank. If you change X, then Y will change. Some people say it's a prediction. If you do this, then you'll do that. If you play classical music to a child as they're going to sleep, then their brain will wire itself and they will grow to be smarter.
If you raise
Children in a very strict environment,
don't allow them sheets
or pillows, and only make them sleep on a
plywood bed,
then it will toughen them up and they won't expect anything for free. That's a prediction. I think the state has something against such a method. You want to write down the null hypothesis. And notice again, we have an abbreviation for it, just as we did for population, just as we did for sample. It's a letter italicized. So capital H, subscript 0. And so, if you can imagine, we don't like the null hypothesis, much like we don't like hoes. Despite what Miley Cyrus has tried to teach us, hoes are bad. So we're going to reject the hoe. Again, unless you are a redneck child growing up in a southern state that ends in A. In which case, I don't know. What do you call a hoe? I should probably stop right there. I just had a line there. I'm like, maybe I should back off from that. All right, so here's what we're looking at. Even I have like a red line. So what we're looking at is, what the heck is a null hypothesis? It predicts that nothing's going to happen. It basically predicts kind of a failed experiment. So the null hypothesis would be stated: if you raise a child with 30 minutes of classical music a day, then there will be no change in their IQ. Let's do this. Be honest. You don't have to write this down yet. Let's do a dork check. Let's do a dork check. There's a kid with the Yu-Gi-Oh cards like, oh, not again. All right, so here's what I'm saying. How many of you all, I know you two are guilty, how many of you all not only love Harry Potter, told you were guilty, all right, and have actually tried to say the spell with some kind of kitchen spoon implement? All right, we got a couple people nodding. How many of you all have done it but are too embarrassed to actually raise your hand right now? This whole side of the room. Okay, so let's say this. You say a Harry Potter-like spell. That's one variable. If you do a Harry Potter-like spell, then you can have magic Jedi powers. And you're going to prove this by, you're going to flip a coin.
you're going to flip a coin 100 times.
And after you say your spell and you do your wrist flick, then you flip the coin 100 times and you find out it worked. 52 times, 52%, it came up heads. And that's what you wanted. That was your spell. It was Latin for heads. And then 48% of the time, it was tails.
It worked.
Didn't? I mean, you wanted more heads, and then now you got that, so it worked. Or did it? The word we need to be aware of is called significant. The word we need to be aware of is called significant. Is your result significant, or is it an accident? Statistical chance, a quirk? Basically, we're looking at, is your effect big enough to matter? If you give 1,000 people a new drug, and it helps one, woohoo! I'm going to publish success. I'm going to sell my drug. We're going to make my drug company millions of dollars. It's not significant. Let's talk about parapsychology.
And we talked a little bit about
Harry Potter. We talked, maybe we haven't talked enough about the X-Men, because let's face it, if it came down to it, in a gigantic school-on-school brawl between the X-Men school and Hogwarts, who's going to win? How many of y'all say X-Men? How many of y'all say Hogwarts? How many of y'all did not raise your hand and refuse to participate in my nonsense? All right then. So what if I could prove? What if I could prove something called parapsychology? Parapsychology is the branch of psychology that deals with telekinesis, that deals with reading people's mind, predicting the future, knowing something that you shouldn't be able to know through your 5 senses. I think a lot of us would like it. If we didn't like it, there wouldn't be so many science fiction and fantasy books out there. Can a researcher disprove this? So the null hypothesis is, if a person concentrates, they will not be able to read someone's mind. That's the null. How do we reject null? And we're going to learn how to design an experiment. How many of y'all would like to see a video right now that shows, I can't offer proof, but it offers pretty strong evidence that somebody can know something without being able to see it? The information just comes. Would you like to see that? Let's do this.
Square.
Good guess, but wrong. Clear your head. All right? Tell me what you think it is.
Is it a star?
It is a star.
Very good. That's great.
Okay? All right. Think hard. What is it?
Circle.
Close, but definitely wrong. Okay? All right. Ready? What is it?
Figure 8.
Incredible. That's 5 for 5. You can't see these, can you?
No.
You're not cheating me, are you?
No, I swear they're just coming to me.
Okay. Nervous?
Yes. I don't like this.
You only have 75 more to go. Okay? What's this one?
There's a couple of wavy lines.
Sorry. This isn't your lucky day.
I know. Wait, I'm getting a little tired of this.
You volunteered, didn't you? We're paying you, aren't we?
Yeah, but I didn't know you were going to be giving me electric shocks. What are you trying to prove here anyway?
I'm studying the effect of negative reinforcement on ESP ability.
The effect? I'll tell you what the effect is. It's pissing me off.
Well, then maybe my theory is correct.
You can keep the $5 I've had it.
I will, mister.
You may as well get used to that. It's the kind of resentment that your ability is going to provoke in some people.
Do you think I have it, Dr. Venkman?
You're no fluke, Jennifer.